Hello everyone, and welcome back to the second episode of ToxStream, this live show brought to you by Tox Academy. My name is Matteo. I'm going to be your host, and what I do here usually is invite people trying to explain me something that I'm not able to understand on my own. That's what this video show is all about. And it's what we're going to talk about here is mainly two things, which are the main passions of Tox, which is the company that develops this show. And what we really like to talk about are alternative methods to animal testing in toxicology, as you probably gather by the fact that we put the word tox everywhere. We might have a problem with that. And the second thing that we really like to talk about is science. We like to talk about what it is, how it works, why it doesn't work sometimes. And if you are interested in either one of these two things, you might find something of interest either in this video or on one of the many activities that we do. You can find us in online. I can invite you to actually look at our website, academy.tox.pe, but you can also find us online on LinkedIn, Facebook, Twitter. We are pretty much in every social media. So I'm pretty sure you can find some activities that are of your interest, and you can also find our contacts there if you want to get in contact with us. But here what we do is bring in experts to talk about either science, either alternative method to animal testing. And as I said, this is the second episode of ToxStream. We had the first one a few weeks ago, which was about science communication, so about science, if you will. And today we start with the second one, which is this alternative method to animal testing, or NAMs, new approach methodologies. You will hear me say a lot of the times these two terms. We will try to explain them during the live, probably during the entire live that we were going to have in the future, because it's not that straightforward. And the way in which we are going to try to approach this subject, which can be a little bit difficult sometimes, is to start from the name itself, new approach methodologies. And we're going to start from these methodologies, from techniques. We are going to have each episode an expert on a different technique, and we're going to try to explain it, how it works, why it's important, and have a discussion around this topic. And you are also able, of course, to interact with us. Actually, I encourage you to interact with us. You can write in the chat. Every time that you have a question, I will do my best to bring attention to our guest, or your point, whatever suggestion you might have in the chat, and we will be able to see it. What we're going to talk about today is, I have to be clear, honest, was a bit difficult for me to start with this specific subject for two main reasons. The first one is that it's a bit difficult to pronunciate the name of the techniques that we're going to talk about today, which is physiologically-based kinetics modeling, which it might be complicated to say, but it's also a little bit complicated to understand, at least for me. And I'm just going to drive you through my mental process when I prepared for this event. Because the first thing I did was to go on Google and type PBK and see, okay, what the hell is this thing? And, the first thing that I came up with was this type of slide, which definitely was not helping me to understand what it is. I'm a biologist. I don't really get along with boxes and arrows. And the second image that I found was basically boxes within the human body, which again was a little bit confusing to me. And for whatever reason, the third image that I found related to PBK was this one. I have no idea what Google was trying to tell me in this case. I was very confused, and definitely my confidence was a bit shattered after this. But luckily for you and for me, I am not going to be the one explaining you PBK today. We have a great guest with us, which was able to explain me what PBK is. So I'm sure that you will understand and learn a lot. She has quite an experience on PBK. She worked a lot on that. She did a PhD in the Wageningen University, and then she moved to the Joint Research Center as a postdoc and then as a scientific project officer. And now she is a principal scientist and lead system toxicology at esqLABS. And I'm very happy to introduce you and welcome on stage Alicia Paini. Hello, Alicia.
Hi.
Ciao.
Ciao, Matteo.
How are you?
I'm fine.
Thank you very much for being here with us today. Thank you for accepting this invitation. I'm very happy to have you here.
Thank you for the invitation.
Okay. I hope that I didn't destroy too much the PBK, but really it was very difficult for me to get it at the beginning.
I hope to clarify some issues. Let's see if I'm able. As I said before, I don't think I'm the expert on the topic, but I know a little bit about it. So I hope to engage you and engage the public tonight in what I have been doing and what I will do in the area of NAMS and PBK modeling.
I'm sure it will. I mean, I think this is rather a scientist problem. If you take a general normal person, you say, I do something for 10 years, I'm going to consider myself an expert. You ask the same question to a scientist. I did this for 15 years. I don't know much about it. I guess it's something related to syndrome imposters. I guess we got just make people feel guilty about it, but I don't know. Anyway, as I said, this is the first episode when we go for alternative method to animal testing, and I would like to try to introduce also the world of toxicology a little bit, because that's at the end of the day why we are interested in NAMS, why we're interested in a way risk assessment and toxicology. And I guess we are interested since probably the first man that died of food poisoning, eating something wrong, and the other guy was like, okay, maybe we should pay attention to whatever happened to that guy. And I would like to start with asking to you, but also to the people home, what do they think about this issue of being exposed to chemicals around us, if we should worry about, if they worry about, or if they not. And before that, I'm just going to show you a very short video that might explain why we should worry maybe about chemicals that are around us, from a show that I hope many of you will recognize.
What's that? Do you see what's approaching there? They look like cell pollutants to me.
I have to say that I loved that show. In Italian, I mean, in English, it's Once Upon a Time Live. In Italian, I mean, when I was a kid, I was watching it. In Italian was Siamo fatti così. I don't know if there is someone on the audience that was looking at that as well in other languages. I mean, I would like to know how it was spelled, maybe in German or in other languages. But I mean, that was a nice representation of what chemicals might do in your cells. And I guess the first question that I have is in that line. And to ask this question to the audience, I would like them to use this app-based called Slido, which is a very easy and intuitive app. You can simply go on slido.com and you can insert this code here, 176561, and you will be able to, oops, I didn't put it on. Oops. If you go to slide.com, you can insert this code and you will be able to join our session. You don't have to install anything, and you will simply see the question that I have for you, which I will also bring in a second. And I will ask the same questions to Alicia as well to start. Share screen. Okay, so the first question that I had for everybody is if you are worried about chemical exposure in our society today. And there are quite some possible explanation, and we can choose whatever one you prefer. And if I didn't put the one that you feel is yours, you can simply write it in the comment. You can see it as well, Alicia, right? I'm just going to move ourselves so you can see it better.
Yes.
Oh, we have someone that's watching it in German. How was saying Once Upon a Life in German? Well, the translation maybe in German. I guess the translation in Italian was something like, that's how we're made, I would say. Anyway, we can let the people vote. And in the meanwhile...
Feels pretty safe. I want to look at Dark Waters, the movie that just came out in 2019, and then tell me again if you feel safe.
It's gonna change your... Okay.
Sorry if I made some publicity of a movie, but it's I got really blown away by it. I watched it actually 2 nights in a row.
Oh wow, Dark Water.
In English, yes, Cattive Acque.
Okay.
It's all about how it started with the PFAS and PFOS.
Okay.
So, and how it contaminated the waters in the area where it was produced.
Okay. No, definitely something to check out.
And it's not the only movie, there are other movies, but this is just the most recent one and also a hot topic. But, yeah.
I just want to put the comment of Joanne of how the show was called in German. I have no idea what it means, but it's always looks a little bit intimidating in German. But anyway, it seems that people, they are pretty happy about it, so they are not that concerned. We'll see what's happening at the end of this video. But to start, as I said, I'd like to start from the definition itself, NAMs. So I said new approach methodologies, which might mean a lot of things. What would be your definition, Alicia? How would you define them?
Yeah, it's not so easy to define NAM. I mean, if I would take just the definition that was brought up by ECHA, which is the European Chemical Agency, the definition of NAM is translated to include in silico approaches, so computational models, in tubes, so in the tube without the cell, or in vitro. And not only you take this information, you also take information from exposure. So as we saw, and information of exposure are epidemiological data, human biomonitoring data, etc., etc. And all of this has to be assessed in the context of hazard and the chemical risk assessment. So broadly, it includes, for me, everything that is alternative to an animal testing. Then what we consider new, it's a bit tricky. But indeed, that's for me what is the current knowledge of what is a NAM. And especially, I think they are trying to highlight techniques, methods that are not yet validated for a regulatory purpose and that need to be used anyhow and applied, because, you know, there is a need to use these alternatives to animal testing. So I think at the end is also the key is to actually integrate all this information and to exploit and make a better use of all the technology that we have. So I think, yeah, more or less the definition for me is for new approach methodologies is as everything that is not an animal.
Okay, no, that's clear. But because what I like of this explanation is that indeed you can have different explanation and approaches to that, but especially the duality of the terms, because you have new approach, new methodologies.
Yeah.
And I guess the first question that I had in mind was like, what would you underline? Is it a matter of approach, or if it's a matter of methodologies?
Yeah. So I think that's also a bit of the confusing part within the terminology. I also struggled a bit at the beginning to understand, because for me, for instance, since the topic of today is these physiologically based kinetic models, for me, PBK models are not so new methods. They have been there since the 30s. I mean, I think in 1937, there is the first report in the literature about a PBK model. And one thing I want to say, sorry, and it's for the clarity of the presentation, that when you look into the literature, physiologically based kinetic models is a general term, but the most used terminology is physiologically based pharmacokinetics, so PBPK modeling.
Yeah, but that was too hard for me to say. That's
yes. So I just wanted to reassure the people that we're talking about the same thing.
Yes.
And so indeed, the technique, the method of PBK model, I would say, is not so new, but maybe because we are now trying to parameterize it using alternative approaches, so in vitro testing instead of using animal data, because the fact that you're using it for an approach which is maybe new, like translation of in vitro concentration to in vivo doses, maybe then in the context we can then define it as an NAM. So then the question is, and I actually would like to ask the audience what they think. What is your opinion? Is a PBK model the NAM, or is actually, for instance, this in vitro to in vivo extrapolation the NAM? Sometimes I get lost as well in what is what. A bit by ECHA definition, it should be just the PBK model. But what is your thinking? If I don't know if they can use the chat to answer.
Of course, they can use the chat. They can write
and,
it. Actually, there is already one nice point actually from George that is rather about the toxicology in general world. That everything can be toxic. It's just about the concentration, which yes, it is absolutely true.
Even water can be toxic.
Even water, yes, absolutely. But yeah, no, I like your definition, because indeed, if I understand well, it's a non-question maybe, because some people may say it's new techniques, some people may say it's new methodologies. At the end of the day, it's both together. We need two ways to understand how to use these new methodologies in the face of how the world is changing, the society is changing, and the toxicological world is changing. And maybe in that direction, because irrespective to the fact that we say approach or methodologies, we say that are new. So I'm assuming that there is something old, and I guess there might be something wrong with the old, or maybe something that doesn't work anymore. And I don't know how you would see that.
Well, I see that more as a kind of evolution. So we have evolution in the science. So we are not just stuck to use animals now. We are really putting so much effort in developing these alternatives. We don't know how much work there is under it, but I think it's huge. And it's not only at the European level, it's really globally. I see it in the international groups that I am, that there is really an effort to go. So science is evolving. Even the computational power that we had in the 30 years ago is different that we have now. So you can really use computers when you go to new approach methodology, so to PBK modeling, and their power is much faster in executing. So there is really a kind of adaptation phase, and so all these new approaches are gaining space, are gaining a role within also the science, but also in the regulatory context, because we have a kind of shift of mind also at the regulatory level. There is a kind of new regulation. So in the US, there is TSCA, which is the Toxic Substance Control Act. In Europe, we have under ECA the REACH, so it's the registration, evaluation, authorization of the chemicals. And then we also have some kind of chemical management plan in Canada. And all these are really trying to assess the chemicals, but also using the new approach methodologies, because it's too much to do everything with animals on one hand. And finally, I would say that there is also societal component, that we said this way. So it's like society is driving a bit. Yeah. And underlining the society is the kind of, how do you say, the emotion component. So we don't want animals to suffer. So it's really key, I think, when you want to translate this from old to new, that everything, so evolution of the science and the regulation, so the changing, adaptation, and also the society impact. And I think also with the, for instance, in 2013, we had in Europe the ban on animal testing for cosmetics. And in this area, there has been a kind of huge demand of alternatives. And there is really the need to have these new approach methodologies developed. Then another issue is the time. It's slow. We are slow. The science is slow, although it's evolving, but also the regulators are very, very slow in accepting. So, I mean, it's all there. I mean, it's I think so.
No, it makes sense. I mean, I understand that is rather an adaptation rather than say, okay, what's old, it doesn't work. It's rather, world is changing, chemicals are everywhere. We're way more than what we had 50 years ago.
And the thing is that you're not only exposed to one chemical, we are exposed to mixtures. And when you go into the mixtures, that I always wanted to stay away from mixtures. I've been a bit working at the JRC on that with colleagues, and it was very, very fascinating, but it was very, very also terrifying. How do you assess all the mixtures and within the mixtures, the composition? do you do this also with animals? It's very, very difficult, I would say. So I think it's better to, kind of screening first with all the in vitro tools and try to really make the whole risk assessment human-centric rather than using animals, which anyhow you need to translate to human on one hand. So
no, that's a good point.
That's my also the need of having this new and to be pro for the new.
I'm going to bring also a few comments from the audience, because I go actually in the same direction in a way, because indeed, maybe it's not PBK itself that is a number, but rather in vitro in vivo extrapolation, which is an objective, I guess. It's also linked to PBK, so I guess it's also difficult to say when one stops and the other one starts. Or maybe I like also this one from Mark-Anne, that what is real new is maybe the use of PBPK, the fact that it's maybe used more broadly, and we will go into that in a moment as well. But again, this I think is just a sign that the field is very active, is very evolving, and
so
it's happening.
The thing in chemical risk assessment, yes, we can say that it's new. I mean, we have only, at least in the US, maybe they have assessed more chemicals. I'm not really good with numbers, but in Europe we have EFSA, who has made some opinions based on some data, and also EMA. So EFSA is the European Food Safety Agency, and EMA is the European Medical Agency. And in EFSA, I know that I think they have assessed acrylamide and bisphenol A, I think, and if I'm not wrong, maybe I'm wrong, but 2, and there is where they use PBK modeling data. And EMA, I know because they have used actually data from my PhD. So that was very interesting to see. But I know that PBK modeling have been extensively used in the pharma world. So it's really sector driven. So there are more than 50 chemicals that have been assessed with PBK modeling, 50 drugs, sorry, with dossier submitted to EMA, if I remember correctly. So
yeah, no, that definitely.
Yeah, so that's new indeed in the chemical risk assessment.
And indeed, the comment of George is also going in the same direction. Is rather an important tool for other NAMs as well, I guess. But as you said before, is a question of integration, of bringing things together to make them work. And going along that, I guess, I know it's a tricky question and probably impossible to apply in that way. If we have these issues with the old way to assess chemicals and we want to use the NAMs to solve it, would it be possible in your case, in your opinion, to pinpoint which is the major advantage of using the NAMs? If you had to choose one, let's say, I know it's a tricky question. It's something that I'm going to ask to the people at home as well. You can also check it on Slido, which is absolutely the same question. You can see it here. The most critical advantage. And again, there are lists of here. If you don't like the one that we put, you can just put another one on the chat. What do you think that we can gain by using the NAMs in this?
Well, maybe, for instance, NAMs can help in better understanding biokinetics. For instance, if you would want to address specific metabolites formation, it's done much easier. And don't say it's an easy task, because doing all the analytics and setting up all the experimental work is not so straightforward. But maybe NAMs can have the power to allow us to kind of better evaluate metabolites that can be formed from the parent compound when we are ingesting the parent compound, and the effect that this will elicit in the cell system. So for me, this would be one of the major key, but it's not only. So I mean, it's the amount of NAMs that are out there. It's amazing. I don't know them all. It's we are now talking only about PBK models, but there are so many, and I'm not going to start because there could be no end. And I think each one of them will have potential. It's just a matter of making the people understand and making it integrated in a kind of assessment way that we can put that. And there are efforts doing that. We have OECD, which doing this IATA, integrated assessment for testing, integrated approaches for testing assessment, I think it's called, where they're using in vitro, in silico information in order to kind of and put them all together in order to evaluate a chemical in a way of evidence approach.
And I think that your reply is absolutely mirrored on the results that we have here, because it's absolutely 50 everything basically. It's important to use the NAMs for.
I like also the collaboration. Of course, it promotes collaboration. It promotes, for sure.
Yeah, I would say that in a way it might even force collaboration, because as you said, I mean, all these techniques we're talking about, I'm assuming it's also very interdisciplinary. You can't really find one figure that can do everything.
There is a paper that I think it's that just recently was published, and it says that in the last 20 years in Europe, 650 million euros were used in NAMs in the last 20 years. And this means that Europe is interested, that there is a lot of, willing and it's just to create more awareness, probably. I don't know.
No, I definitely agree. And okay, that I think it was a bit tough to start with, so maybe we can ease up with more. Another question that I always like to ask to anybody, which is, how did you ended up doing that? What was your path?
So by chance, I'm actually as a background as I'm a food science and technologist. So I had no idea what an NAM was until 10 years ago when I joined the European Commission Joint Research Center and the esqLABS laboratories, and I arrived there just because I applied several times, and finally at the last time, So don't give up. That's one thing. When you really want something, just go for it. And as you said when you introduced me, I was there first as a postdoc in research, and I did prior to that the PhD at the Wageningen University, and together with Nestlé Research Center in the area of PBK modeling and how to parameterize the PBK modeling using alternative approaches. But at that time, I was a bit naive in all the alternatives, and I was really saying, I have a model. I parameterize it with in vitro data. I really want to do an in vivo study. Sorry about this to say that. And I made an in vivo study in order to validate my PBK model. Ideally, now I would not have done that. I would have put much more effort in trying to reproduce or try to use other techniques. We saw some comments from George Laizou, and he's using a lot of global sensitivity analysis, which can help in better assessing your models. And I hope that will be one of the keys of the future, in order not to have animal data to validate, or it's just to do a PBK model for human assessment, and you build your human model and you use your human data. As I said, I just applied several times. I got in as a postdoc. I had to shift my mind from more food-related issues, because my PhD was on alkaline benzene, which are carcinogenics that are found in plant-based, so in basil. Like in Italy, we eat a lot of pesto, and it's found there. So, but it's not, the levels are not so high, depending, of course, then on the plant. But it's okay to eat pesto still. There are other factors that inhibit, the whole pathway of metabolism, so like garlic, and so it's okay. But let's not go towards this other thing, because I've always been fascinated about food and what is in our diet and how we are. But then I arrived there in ECVAM, and I was taught to do more on cosmetics. So I entered the sector world of cosmetics, and it's totally different. So that's where the mind shift came, of using alternatives, using really, trying to assess everything without the use of animal data. And the first project I was CERAT-1, which was a very huge project, 50-50 by Cosmetic Europe and the European Commission funded. And it ran for 5 years, and it was quite productive. I really enjoyed that time. And after that, I remained at the JRC, and the nice thing was that I was told to actually start translating the science that I was doing before into regulatory context. And it took me a while to understand what that meant. But at the end, I did it. and it was very, very, very nice. I liked it. And there is where I have to also thank my previous boss, so Maurice Will, and the fact that he just allowed me to go anywhere. He said, you have to network. The word here is really network and go. And actually, one of the first few people that I went to meet was in the US. I went to meet John Wamba. From him, I met Cecilia Tan. And then I met all the other folks on the PBK modeling side, Harvey Kluhl and Hugh Barton, Mel Anderson, all these people. And it's really fascinating world and community, actually. And after that, also I went to Europe to visit other people, and also George was one of them. I actually went to the UK to visit them. And yeah, so that's a bit the experience. And what I can tell the audience, if there are any young people that like to hear this, that really networking is essential. It's a bit difficult now with the pandemic, but I hope it will become soon normal again.
Well, of course. I mean, these videos are also an optimal opportunity, I'm going to say, if you want to find people interested in what you like as well.
Yeah, exactly. And now, you know, and the thing now in my line of work, where I'm now at the esqLABS, which is a German firm, I really like the fact that from science that I did in the PhD, and then going to translate the science into regulatory, and now I'm on the side where they are actually applying. So the group I'm working with, they're really, really great people, and they're really doing a lot of, you know, efforts in modeling and making modeling and simulation for this using PBK models and disease modeling. So it's actually great to be part also of this team.
Mm-hmm. Okay, no, it seems very a dynamic field, definitely. But I guess now it's unfortunately time to really dig into the PBK. You know, might be hard.
Sorry.
But no. I mean, we also have some questions from the audience that I will come back in a moment because they are more hands-on. So I guess we can start with, okay, what is PBK? What does it stand for? And maybe we can even use one of these dreadful image that I was not really able to understand, but I'm sure that with your help we can be able to get.
So yeah, so as you can see from the figure, physiologically-based kinetic models, or so-called PBK models, can be used to simulate chemical throughout your whole body, and this is driven by absorption. So by after you, let's say you take your cup of coffee in the morning, you will get your shot of caffeine, and this will actually go through your whole body. And PBK modeling allows you to kind of predict where it is distributed, where it can be metabolized, and where when it can be excreted, and also, of course, absorbed. So that's the ADME, so-called ADME processes: absorption, distribution, metabolism, and excretion. And these mathematical models are all driven by, most of them by ordinary differential equation. And so yes, you can represent a human body, as you can see on the right side of the slide, but you can also represent animals like a rodent or even a horse, farm animals. And I know that a lot of effort from EFSA was also to model farm animals, and also the cat for pet food. It can be, you know, for pet and pet disease. I don't know, and so it's the cat and the dog, especially. And dog is more for second species, but testing.
But it's super fascinating because basically, if I understand, you take an organism, and you break it down to mathematical equations, which is black magic for me. No idea how this could work. And I also have this impression, you know, I did a PhD in neurobiology, was always not working because I was working with stem cells, which they don't work. Basically, they always have an issue. But if you work on computational models, what does it mean when an experiment doesn't work for you? I'm always picturing someone, you know, drawing on a blackboard, and then at the end of the formula, shit, I forgot to do this. How does it work?
I can make more that doesn't work. It's more like at the end, I can make an example there. So within my PhD, I had to parameterize my PBK model using the in vitro data, and I had to assess the distribution, absorption, metabolism of the chemical estragol and its metabolites. And what happened was that when we did this in vivo study that I mentioned before, it didn't really fit the results of the in vivo. It was overestimating. And so how to dilute? So we needed to understand how we could better dilute. So we went back to the literature, had to understand the processes within the liver, because the liver was our target organ. And so we actually zonated the liver, because the enzymes that are in the liver are in different areas, and as an abundance is different. So this allowed us to kind of dilute and make the prediction better. So at the beginning, we can say it didn't work. And then because of, understanding more and interacting with the models, we could come closer within factor 2 of the model of the in vivo prediction. So actually, for me, it was a success, because I really enjoyed it. This struggling. Oh my God, I can't publish this like this. I need to. and then, but then it went. So, and I was very, very happy. And I have to thank there also colleagues at Wageningen and the professor Ivona Richens and Hans Punt, which helped me a lot in establishing the whole model and my PhD, and also all the people in Nestlé Research Center.
I understand.
So
I guess the issue for me was always to come back and understand more. I was doing an experiment, understanding less, do it again was not working well.
It was more when I had to set up the analytics or for instance, when I had to do all the in vitro techniques. Yes, I had a lot of gaps there. So part of this was to kind of how do you say, first thing was to actually synthesize the chemical that allows you to quantify the metabolite in your analytical LC-MS, so this liquid chromatography. And I luckily I was helped by some chemist to do that. But I had the rotavapor and I had all this, and of course the first time the color didn't look yellow. It was kind of whitish. So we throw it away and we went again. And then at the end, after the third time, I was happy. The other thing was during the PhD that I was able to change 4 LC-MS because I understood afterwards, because I did my PhD within the facility of Nestlé, that they gave me all the old machines so that I could just go. No, it was very good, because I went there, I did trial and error by myself, learn how to do it yourself. And of course, some of them just took, but luckily were just the old machine that they were not using. So I had to, change and change and change. I mean, I said like this now, like past, but it was struggling, and you're frustrated because maybe you work on the machine for 4 or 5 months, you calibrate it, and then you have to change it because something went wrong. It's not working anymore. So, and starting all over again. So that's the PhD. That's life.
Yes, I guess it's a tale of any PhD in a way or in another. Good time. It's done now.
Yeah, I would go back actually.
Really?
I would go back. I liked it.
I guess I have to wait a few years to have this going back. But okay, I understand in a way how you can make it work in principle. But there is a question also from Meg, and that is also going in the direction where I want to go now, which is rather than talking immediately of exactly what you can do with that, or rather what people are actually doing right now with PBK, is how do you make sure you know it works? And here she puts a possibility. I mean, that you do need in vivo data at some point to figure it out is what you are doing is right or not. And more in general, how do you test your model?
Physiological data, physiology. So, I mean, I assume body weight and all the physiology that describe either an animal like something that is not a rat, but let's say a human or a species that you're interested to model. So for instance, a dog or a horse. That was one of the picture, because you maybe want to go for a veterinary use and you want to build a model and see how a drug would, be up. So, all this information you need from in vivo study, but I assume that you don't really need an in vivo. You need the in vivo information, but you don't need an in vivo study to parameterize the model for this issue. You can find historically.
Okay.
You can, so historical data from the literature, from other, you can weigh your animals. So, I mean, there are some non-invasive things that you can do. The partition coefficient, you can use QSARs, so which are a quantity structure relationship that allows you with chemical properties to like the lipophilicity of the chemical allows you to better understand the partitioning within the tissues of your chemical. So we are now parameterizing using this type of approaches, which I don't say that are correct. I mean, it's a way. They have been established. It's a main question about applicability domain, and there is a lot of this ongoing discussion. Also in the groups that I'm working now with at the European level. So esqLABS is actually part of OnTox, which is this new EU-funded project together with Risk Hunter and Precision Tox, and the three big EU projects that have started last year. And they are trying to develop NAMs. And we, as esqLABS, are doing the PBK modeling part, and the kinetic domain we are leading within the project. And together with Nienke Kramer and Susanna Proenza, we are trying to establish also there what is the applicability domain of models that are used to parameterize the PBK model or other computational models, and also the gap analysis within a PBK model and within this type of computational models. So indeed, an in vivo component, it has to always be there, but hopefully it's not animal. Hopefully, if we are talking about human health risk assessment, it's human. So we get the data for human.
Yeah, no, indeed, that's indeed would be also one direction in which I would go in, because if I understand correctly, you can use PBK indeed for many different applications. And I guess even just thinking about the fact that you can model different species, it's also allowing you to do many different studies, because it's something that maybe we don't think about it that much, but we have to test also the thing that we use with animals, with pet animals, and is part of the toxicology studies as well. And I guess you can use it also in a way to do a few specific studies, for example, on subpopulation of the population. And I guess, and you, in that case, I guess you don't need animal testing, but I guess you can get human data from other type of studies.
Yes, you can get polymorphism data. You can do also there during my PhD. We assessed using a microsomal fraction for 22 donors. So we used this and we built up a human PBK model for estragol, and also that would kind of simulate the DNA adduct formation for these 22 individuals, which went from different life stage, from 0 to 98 years old, I think was the age. And the thing is that, of course, also the costs played a role there, because we are the university. It was difficult to get. It's difficult to get samples, and but what you can do with the model is then kind of try to approximate and make then Monte Carlo simulation and amplify your population to kind of how you say model.
You can use it's a statistical method.
Yes,
I guess
of
I'm not an expert on that.
1,000, 10,000 based on your starting point of this 22 individual, and we have performed that, which was also very interesting. And another thing I like is the life stage application. So going either for an adult or pediatric. It's also very interesting. And we're also trying within OnTox to go for developmental neurotoxicities. So as an endpoint, so we'll have to try to use kind of pregnancy models, PBK models, and see. I mean, it's still a question mark how we will do all this, but we are going to try to put together all the information.
No, and I know that there are different, let's call them bank, when they have a lot of these kind of samples in general. I mean, there are also other projects in which we are involved that you can find it out in our website, where we use cord blood or blood for different kind of cohort studies. And it's really interesting that these kind of studies are being used now. It's super complicated for what I understand, but it's going to be very interesting to see in the few years, in the few even months, see what will come out from these.
Also from omics data, how to,
omics data.
One day to integrate all this. Exactly. But
no, well, that's super clear. And I mean, maybe now we can go more in the direction of okay, we understand a little bit how PBK works, what we can do with that, and what we are doing with that right now, what people around are already using PBK. And you sent me this slide, which seems it was very informative, and maybe you can walk us through this survey. It's from the GRC, right?
Yes, was one of the work that started my whole translating the science into regulatory, and it was basically together from GRC, but together with US EPA. So with Celia Tan and her team, that we drafted the survey to try to map how and who and where all the W's of PBK modeling. So where are we? What was the present state of art? And so at that time we had 98 respondents to the survey, and one of the questions was for which application do you use PBK modeling? And this just gives you an overview of where these people. So it's not representative of the global, but only of these people that have answered the survey. Mainly they have been using it for health risk assessment and then exposure assessment, chemical safety assessment, and then experimental and drug design. And so it's the first three, I think they fall more under really the toxicology domain, as we are discussing today. And the next are more about pharmacology. And then we have the ecological, so environmental people, and finally the veterinary. And in others, I don't remember if that was then specified, but I have also the feeling that PBK modeling could be used for forensics, for instance, where you could, try to help in assessing a drug by knowing the concentration maybe in the hair, if you would add a hair compartment, because sometimes you find them, they accumulate there. So, and you can maybe in time understand when this was used, or for instance, when there is an accident, you can also there try to establish the time frame. But yeah, this is more futuristic, I think, but it was something that I also liked to see, to read. I read it somewhere, so it was very interesting.
Oh, it might be some new venue for new scientists if they want to go, if they are dreaming of some CSI future from them.
And I have to admit, I'm trying with some folks that I worked on together with Annie Lumen and her team at FDA, trying to do some kind of hobby PBK model for forensic. We wanted to try to do something, but we never managed. It was like, when you are in front of the coffee machine and you discuss and you're really into it.
Coffee machine networking, yes.
And it was very, very... and we will see if something we are trying to draft something. But not as straightforward. But
no, but it's great. I mean, my understanding, of course, is that I see that is used mainly, from this survey at least, from toxicological studies and risk assessment. But indeed, there is a broader use of PBK, and maybe now it's even changed. I mean, now it's 2017, and I know that things tend to change very fast.
With other people, we will. I've been talking a lot with Judith Madden from Liverpool John Muir University about actually having a follow-up of this survey. And what we aim, or what we would like, is that there is actually an increase in numbers of replies, so from 98 maybe to go to 150, just to show that actually the community has increased. And I think it has. When I started in 2007 my PhD, I didn't know really what was a PBK model. I just came fresh, from food safety master, and I just knew the basics. But I got fascinating, and I know that there were always there are always the 3-4 main actors that have always been there. But now slowly I see that the community got bigger, and with 2017 when we were at SOT, Michelle Embry, working at Hazy, tried to put together a team of PBK modelers. So there is actually now a Hazy working group on PBK modeling, and we are trying there to to address all these issues that we discussed today. So how to more exploit PBK modeling in risk assessment. So if you're a PBK modeler and don't know about it, please go to the Hazy, HESI, and see and ask if you can member of the group. We welcome people.
Initiative. And we can actually bring that one other comment from the audience, which is another initiative, I guess, some models for POP, which I don't know what it is.
Persistent organic pollutants, or not.
Okay.
Yes. Correct.
Okay, I guess there are ways to model placenta transfer and lactation, which, it's a way. It's also a super interesting topic of how we are affected by chemicals even before.
I will have a look at this paper to see how this could inform the development of our own gestational pregnancy model. Thank you for this.
And maybe to conclude, because our time is almost running out, we said how it works, how we can make it work, and it's been used already. What do you think are the main challenges of the limitation of PBK used in the regulatory landscape? What we can do to make it more used?
So if you go back to that paper of 2017, to that survey of 2017, there we defined 5 main challenges and limitation, let's say. But if I can tell you already now, I would say that they are different, but I would check once we would do this survey to see the answers. But there is one, it's the lack of expertise. The answers from that survey was that one, there is a lack of expertise in PBK modeling and the application and how you apply it in a regulatory context or by risk assessor. But I think now this is quite changing. There is a more shift mind of course, because NAMs are becoming, the tools. Also, PBK modeling are gaining more and more place within the risk assessment. So maybe the expertise it's not there as a PBK modeler, as maybe building it, but there is more and more understanding of how it works and how it can be applied and how this data can be used within the risk assessment context. So that's a limitation, a challenge that at least I think it's getting towards a positive outcome. Then, of course, there is the validation issue. I didn't want to bring in the word validation because it's not easy to define. But when you validate, you need to do this. You have your model, and you need to validate against real data. So, and for us, it's the in vivo data. And if you don't have this, how do you do that? And you have to assess so many chemicals, and so many chemicals are unknown, and for which we don't have all this data. So how do you do that? And that led actually to kind of the effort at the OECD that we had on building guidance for PBK modeling. And there is also where George Laizu, that just commented before, said used the global sensitivity analysis to show that how this could be done without, for data that are poor. So for chemicals that are poor in data. Yes.
Okay.
But yeah. Then the other thing was that of course the software are not so easy to use. Sometimes you need, to have really nice shiny app that allows you to, to apply the model. And I can say now that I had some hands-on the tool of esqLABS that is working on the PKSIM. It's quite easier than what I did in my PhD that was really developing the code in Berkeley, Madonna, because there you just select and you can enter the, and it's very, very nice. But then the regulator will say, I don't know what the model is doing to the equation. So, but then for the PKSIM, they're open access, so you can then go underneath, behind the thing and get all the information. And finally, that there is differences within different agencies and criteria to, in acceptance criteria of between agencies and countries, between Europe and the US. So ACA, for instance, does most grouping. The US is more, prioritizing. So it's all different. So let's see if we do a survey in a year or so, how this will result. And finally, again, it's the dialogue between modelers and regulators. You have a dialogue. You should always have a dialogue when you do an in vivo study between a statistical person and your, in order to, to have maximize of your animals. And there should be always a discussion between modelers, statistic people, and so all stakeholders. So it's always similar. And there we really need to dialogue among all the stakeholders and all the people involved. And I think this is something key for also all the NAMs.
Well, right. I guess once again the word is integration and
also terminology. And I don't want to start with the whole terminology thing because we can go on another hour between pharma, and already you can see between PBK and PBK. We like to call it PBK because it's more general, and also in between validation, qualification, evaluation. But tonight is not the time to go into all this, but just to tell the people that are all these languages, these differences. And if you go to one person and you say, oh, I'm going to qualify your model, and he's like more environmental or more chemical, I say, what is qualification? What is qualify? You really tell him, okay, we will evaluate, because then you are afraid to say the word validation.
Okay, so language is also important.
Terminology is very key.
I see. Okay, well, thank you very much for all this talk. At least for me, it's everything is a bit clear. I hope that for the people as well.
One last thing, I would like just to thank all the people that I've met throughout this last 15 years and of my career, and it has been amazing. And so thank you all, people at JRC, in Wageningen, Nestle, and all the people international that I meet. It's amazing how I think everyone wants to put some of themselves and try really to push forward chemical-free environment and try to assess this with using all these alternatives. So thank you.
It's a very fascinating field indeed. So I thank you very much again, Alicia, for your presence here. Everybody who was listening to us, you can come back to Alicia, I guess, if you want on LinkedIn. You can find her contact in the event page if you have some other question for her, and you come back to us. Once again, I will put you here the name of our website if you want to know a little bit more about what we do. There is also our contact, my contact. You can bother me directly if you want. I'm always happy to discuss with whoever is interested in what we do. And we will be back in a few weeks again. This time we are going to talk about something more, not NAMS again, but more on the science, which is, even NAMS is science, but it's the other pillar that we have. So stay tuned with our social, and you will see what we're going to talk about in a few days. And again, thank you very much for being here, and see you next time. Bye-bye.
Bye.